These are the PM midterm answers. Stop this for the matching. The rest of the video will concern the technical questions only. AM number 21 is to solve for dynamic pressure if you're given the sea level density, it's just 0.00238 slugs per cubic foot, and the aircraft velocity at sea level, which is 92 feet per second. So if you substitute that into the formula, dynamic pressure equals 10 pounds per square foot. 10 pounds per square foot. For AM22, we have a symmetrical wing, and we're looking at the stall angle of attack. So we see a maximum C sub L of around 1.3 at the stall point, and then that gives us a angle of attack of around in the vicinity of 17 degrees. So AM23 asks us for the wing loading at landing. Well, we know that from 21 that dynamic pressure is 10 psf. The dynamic pressure here is Q, and that's 10. And we know next is Q from AM22. We know that the C sub L is about 1.3, which you can see from here at stall at 1G flight. And then if we go back to our basic equation, which is shown here, our basic lift equation for C sub L equals lifting pressure over dynamic pressure. Well, we know Q is 10, and we know C sub L is 1.3. So our wing loading, our lift over wing area, must be 13. 10 times 1.3 at 13. And we know it's 1G because it's landing. So at landing, lift equals weight at landing. So NZ equals 1. And the dynamic pressure at stall is going to be 6 pounds per square feet. So at 1G stall, he has 6 pounds coming in. A good test question would be, what is the lift pressure? Well, if C sub L is 2, if this is 2 and that's 6, what must the lift pressure be? 12, right? So the lift over wing area must be 12. That's the kind of thing I would ask you on a midterm test or on a final. For the last two problems, given that the stall speed at 1G when you're landing is 92 feet per second and dynamic pressure is 10, can we find the maneuvering speed if the maximum G's are 9 at the same CL max of 1.3? Because we know that the CL max never changes at stall. So what is the maneuvering speed needed to reach the maximum G's given as 9? That's called maneuvering speed. Well, the idea is to get 9 on the top and the bottom of the basic equation. So given that the stall speed is 92 feet per second at 1G, what would I have at 9 G's? If NZ was equal to 9, to keep the same maximum lift coefficient, the denominator has to increase by a factor of 9 also. Then the 9's will cancel, and I'll still end up with 1.3. Well, you see that if I am 3 times the stall speed at 1G, that 3 will come out when a 3 squared and become a 9. And the 9's then will cancel. So the maneuvering speed is 3 times the 1G stall speed, and 3 times 92 is 276 feet per second. That is the maneuvering speed in order to get 9 G's. If I go faster than that, I'll be able to pull more than 9 G's, but I will maybe pull the wings off the airplane. The last question is AM25. What's the max wing loading at 9 G's? Well, if, again, C sub L lift coefficient has to be 1.3, we know the weight over the wing area is 13 from the first problem at 1G. So if NZ goes to 9, you'll end up with 9 times 13, 9 times 13. So your wing loading will be 117 pounds per square feet at 9 Gs. At 9 Gs. And of course, a 9 over here means that your dynamic pressure will go up by a factor of 9. So your dynamic pressure at 9 Gs will be 90 pounds per square foot, since it was 10 pounds per square foot at 1 G. That's it.